So thanks to the author, right? So because of them, we can use the data set. So anyway, so when you click to the data set, you have this supplementary data. So you click on that, and then, well, essentially you can just download it. Okay, but you don't have to, because I have already done it for you. So so here, this is the tutorial folder where I have put the Excel file. So this is the Excel file that you can just directly download. Okay, and then I think even what you can do is you don't even have to download the data. You can just copy this link. Okay, so right click on that and then click on copy link address. So let's open RStudio, because for this, we don't even need to talk about all this, all the projects like creation project, etc., right? So we can just go ahead with the with RStudio. So can you see my RStudio? Hey, Tosin, are you still there?
I'm muted. Yes, I can see.
Okay, okay.
I'm muted.
So as usual, you just create a script. So you can click on this button, or you can go to File, create new file, and then R script, right? Whatever you like, it's up to you. So when you first, as usual, when you've created a new file, you have to save it, right? It doesn't really matter where you save, but you have to remember where you save. That is like the basic. So I'm going to save it on my desktop. Okay. So maybe I would say like database ggplot2, something like that. Okay. You can give it whatever name you want. Save it. Now, before we import anything, we have to install a few packages. I think you have already done it, but like for those who haven't done that, what you can do is you can read the instruction to install R and R Studios if you haven't done it, right? And then you can go to this link, download it, put it in a folder, whatever. And then you can also, follow this and name it as a exercise.r. But I just name it as a database ggplot2. So it doesn't really matter which file name you use. So what I want you to do is copy this code. Okay. If you don't have it, I can put it in the chat. Do you have it? Or maybe you can copy text from chat box, I guess. So maybe, yeah, just open this. Have you opened this file? Just copy this code, because there's already a copy button. Just click here, and then instead of pasting here, you just paste in a console. Okay. Yeah. So paste it and then run it. So essentially what it does is, if you don't have these three packages, it's going to install it for you. But if you already have installed these packages, then it will do nothing. Okay. Except it will create a few values in the environment. It is okay for our purpose. Okay. Let me know if you don't, if you're not clear, or
Oh yeah, I'm clear.
yeah.
So
Okay,
like, is this another way of like installing packages? Like if you already have like the code, you paste it in the console, right?
yeah. So like we discussed the other day, there's another way to do that, like you install one packages one by one, or you can do this. Okay, you can just create put all the packages you need in one object and pass it through the loop.
Okay.
So it's going to install like everything if it's not installed already. But it's like it's okay if you want to do it like one by one by install the packages, or like you can click here and then you can just write. Okay, it doesn't really matter. I just don't want people to feel like an extra step for like additional steps just to install a few packages. So yeah, I mean, I just wrote this so that people can easily install packages. But anyway, let's go ahead with it. Okay. Okay, the first step is before we do anything, we have to like conceptualize what we are going to do, right? So imagine what we are going to do. We are going to create graphs, but how do we do that, right? So I have created a few points which we should have followed to understand our data and to get what to graph to get the graph we want. So first, like it should always come from your research question, right? So you have to basically write down your question with research question one by one, and then you look at your question and either find like variables that you need from your data set. Okay. And then after you got your variables, you import your data into R. And then 4, 5, and 6 are basically like checking if there are any missing value, looking at the data structure so that you know your data set. Then step 7 is the actual creation of the graphs. And then after that, basically you look at your plot again and check if the plot is what you want. So basically like challenge your solution. If it is okay, then yeah, you can save it or you can copy it. If it is not, you go back to, I don't know, you go back to 1 or you go back to 7 and then restart the whole process. Okay. Okay, so basically, when we think about the graph, first we need the data set, right? Without the data, you cannot create anything. It can be like a line list, which you have like one row, one patient, the kind of line list data set. Or it can be a summary number, like aggregate, right? Mean and standard deviation, or maybe frequency, number and frequency. It can be a summary aggregate numbers. So the data is important. And then you need to think about where you want to put your axis, okay? What you want to put on your x-axis and y-axis. So these are the components, okay? These are what we call it a statist, okay? The sort of like the structure of a graph. So without x-axis, y-axis, you cannot draw a graph. And then when you have the x-axis and y-axis, then you need to think about, okay, what kind of geometry you want to put, right? It is sometimes called the data points, or it is a point, or is it a bar chart, or is it a box plot, or is it a violin plot, or is it a combination of all these things? Okay, so you need to think about it. So after that, essentially, after that you just need to modify your geometry or the data point that you display here, so that you can compare groups. So as I said, like it is always it is the best when you have a comparison groups, okay? Because whenever you uh well when you have groups, it is easier to compare. But anyway, you can modify these geometric points to get, color, to get shapes, to get size. Simple things, but these are also important. So here in this graph, I've shown the data point on x-axis and y-axis, and there are 3 groups, 4, 6, and 8. 4 represented by red dot, red cycle dot, 6 represented by green triangle, and then 8 represented by the blue rectangular, right? The square box. And then you can, after that, you can modify a bit and add like names, modifying the names, like names of the labels, x-axis labels, y-axis labels, and the titles, and also the legends, right? And you can decide whether you want to show the legend or not. So essentially, like, this is a very simple graph. Like, we can talk about like the whole day about all possible graphs, but that is not what we are going to do. Okay, so right now, this is basically the idea of ggplots too. So remember, we are going through all these steps by adding one component after another. So imagine we have data set. Based on that data set, we put x-axis and y-axis. And after that, we think about the geometry, whether it is a point, box plot, bar plot, histogram, etc. And then after that, we think about whether we want to put groups, colors, shapes, size, etc. And then after that, we modify, like fine-tune the final graph, right? So, any question?
None for now.
Okay, should be pretty straightforward. Okay, so let's go back here, and then I would just copy this, copy link address. What I'm going to do is I'm going to move to R, and then I will say read XL 2 colon. Okay, so, well, you already know this, but for those who don't know, this read_xl indicate the package name, which we have installed earlier. And then 2 column indicate that the function that is coming from this package, right? So the function is read_xl because it is the Excel file, right? And then we can put quotation and paste the link that we have copied. Okay. So you can follow this step. And if I'm going too quick, then let me know. Okay, so I can just write it like, okay, this read_xl indicates package name. And 2 column is telling R that the function is from read_xl. Then read_xl is a function name, right? So function always followed by brackets, right? So this is the start. And then to run this, you can put a cursor anywhere and then click run, or you can click control enter. Or if you're using Mac, and then that is command enter, right? So that is control plus enter, or command plus enter to run the script, not the script, to run that command line. Okay, so let's do that. Apparently it is saying that there is no there is no, the path does not exist. So that is tricky because well, because because I think Excel does not work with the what do you call it, the link, right? So what we are going to do is we are going to copy this code. Okay, so get in the data set, we can just copy this code. Okay, and then paste it here. So don't worry about it. Essentially what it does is it's going to download the file, the Excel file, to your computer. So sometimes it really depends on what kind of uh, it it does not really it has something to do with the file hosting services behind the genre, right? So essentially this link does not respond to R to download it directly. So what we have to do is to download the file using a different function. So we do this. So imagine, so basically we are in a document folder, I think. Okay, or the home folder. So anyway, this should work because it is going to be the same because we will be running on the on the same script, right? But what I want you to do is just check. So you can change to the to the folder where you save this R script. So we can do this by clicking session and then go to set working directory. And then you can just do to source file location. Okay, it's not very difficult. So what you have to do is
that to link it with the file you've already created.
yeah. So what it does is as long as you open this R file, you go to session, you go to set working directory, and then choose this to source file location, which means that we will change directory to the file where this to the folder where this file is located. So that is what it means, right?
Okay.
So but you have to open this file, this R file, R script file, and go to session, set directory, and to source file location. So essentially, earlier I saved this script on my desktop, right? So essentially, this is now set w main set working directory. Okay, so I can just copy this, and I don't know. I can just put it here to the top. So set wd mean set working directory, which basically mean is changing directory, right? Changing folders, folder directory. So don't worry about it. This is recorded, right? So in the case you miss something, then you can always go back to this video and then we can talk about it. Okay, so what next? Then so this is important, right? So because we want this script file and the Excel file that we are going to download to be in the same folder. So this needs to be done first. Then after that, we are going to run this, right? So before I do that, I on the right button on the right bottom corner, I just choose this file tab and then basically click on this reload. Okay. Anyway, if there's no work, then you can just do what is called the go to working directory. Okay, so essentially this folder will take you to the desktop in my case, right? So essentially it's a good way to navigate to your folder that you have set it recently. But anyway, let's do that. Let's download it. So I'm going to run it, and then you can just observe here. It's going to download the Excel file in this directory. So you see the file is only 46 kilobytes, so it's very quick. And now we have the file in our system, okay? Okay, so do you get it?
Yes.
Okay, now, so what we do is we just remove this link, because we're not going to link, we are going to use this file name. So you put the cursor between the quotation marks and then press tab key. Okay, that will bring up the auto suggestion box, which essentially you can choose. Okay, you can use up arrow, down arrow key and press enter. So choose the Excel file and then press enter. And then you click run, and it's going to give you the output. So we can minimize this. So it's going to give you the output of the data set. So do you get it? Up to
Yes.
this. Okay. So basically this is the data set. But if you inspect this Excel file, so this is the Excel file, and then you will notice that they have a different data set for figures. Okay, so figure 2, figure 3, figure 3, E to H, figure 4, etc., etc. So basically, we just put the file name. We didn't specify anything. So, which means that the rig underscore Excel function is going to read the first sheet, the first Excel sheet. But we want to control that. So we will specify which sheet we are going to use. So to do that, you put comma, or you can continue writing, or we can just press enter to go down, and we can say sheet equal and put code in quotation, and then let's check the data set once again. So this is going to be figure space 2, right, with the F, capital F. So we have to write the same name, figure 2. Okay, since this is a figure 2 data set, we are going to give a name. You can give any name you like, but I'm going to give figure 2 DS. So it just essentially means figure 2 data set. Okay. So before we run anything, we'll say import data sets for figure 2. Okay, so let's run that, and just observe on this environment window what happens when we run this script. So it is only a few megabytes, right? So and a few lines, like 36. So it has only 36 observation and 22 variables, so it's really quick. So you can see that we have our data set in the environment. Do you get this?
Yes.
Cool. Any questions?
No.
Okay. So let's continue. So we got our data set 1x, right? So earlier we have already have a checklist, like we have done this step 3. So step 4, we check STR and head and tail, and we check their number of observations and missing value. Okay. So first, we will check structure. Okay. We just denoted by STR. So STR figure 2 DS. Okay, let's run this. So you can see that we have a 22 variables. So these are 22 variables. So the structure of the data set is the first column is Seaman of from alpha 2 A, and the second column is for CBS from alpha 2. So you see the pattern, right? So one column, there are alternating columns between Seaman cytokines and CVS cytokines. So Seaman cytokines, CVS cytokines. Okay. And now so this is the structure. Okay. So don't worry about what these means as of now. But so this is the structure of the data set. Now we check the head. So essentially what it means that check the first, I don't know, 6 to 10 rows of the data set. Okay. So we just look at the first few rows. So here we look at the 6th row, right? Value of the 6 rows. So by doing that, you can just look at the value. Okay. So usually cytokine values are positive. And then we got a NA, which is a missing value. Okay. So we can just say NA is a missing value. So it's a blank. And then you can just check whether these number make sense or not, or if there is any outlier, just, eyeballing. And then the same way, we can check the last. So this is checking the last 10 rows of the data sets. Okay. Then we say tail, which is like the tail. So we are checking the last 6 row, right?
Neil, I have a question.
Sure, go ahead.
My question with this head and tail is like, is it by default it displays the 6 to 10 rows? Because I'm not sure how is it that we indicated to us that okay, 6 to 10 rows we want to see.
Sorry, I didn't get your question. What is your question?
About the head to tail, the head and tail function.
Yeah.
How do we indicate to how that is 6 to 10 rows we want to see, or by default it just gives the last 6 rows from the first 6 rows?
Sorry, I'm not
Okay.
sure I get your
So
question.
I'm asking. So like you wrote the function head, then
Yeah.
indicated the data set. So I'm just asking, like, if by default it just shows you the first 6 rows, right?
Yes.
Is that if you want to indicate more than 6 rows, is there a way to tell us that I want to see probably like 12 rows, the first 12 rows?
Yeah. So what you can do is you can specify n value, right? So you put
Oh,
comma and then n equal, I don't know, 10.
okay.
So that will give you the first 10 rows, right?
So,
So you can do, I think, up to a few, like 50 or 30 or 50, right? So because they are like a maximum value that you can print. But other than that, like if you have a long list, I don't know, 100 or 200, then it's not really useful to look at all these, because it's gonna be a long list, right? But like the first few rows, looking at checking the value is a good idea. But don't,
okay.
yeah, so if you want to change it, then you can also do the same, right? To the tail, that you can say, okay, maybe let's check the last 15 rows. So you can specify that. But by default, it is set at 6 or maybe 10 in other cases.
Okay. Thank you.
Sure. And okay, so how do we check the missing value, right? So the easiest way is like put a summary, and then so it's a function, so it is followed by brackets, and then fig to ds. So by doing that, you can just look at basically you can check a lot of things with this function. Okay. You can check minimum, maximum. So there is range and mean. so mean and range. And you can also check median and the first quartile and the third quartile. So you have median and interquartile range. So it's like a summary measure, which is, basically the name. But the point is not that. The point here is to check the missing value, right? So it is a good data set because we only have one missing value in Siemens IL6. So it's a good data set. And you can also check like the plausible range of values, like for each cytokine. So say, I don't know, maybe for Siemens interferon alpha 2A, maybe if got like, I don't know, the value 1,000, the value 1,000, then it might be an outlier, or it might be it is beyond the plausible range of value. So it is a good idea to just check these minimum maximum values as well. Anyway, so we can just say that summary basically gives you summary measures that you just check minimum, maximum, and NA, which is missing values. Okay. Now we got that.
Quick question though.
Sure.
Just like curiosity. So this summary on the console tab, is there a way to like export it if you want to have that record like not on R?
Mm-hmm.
It's possible to export it outside of R.
I wouldn't suggest I wouldn't suggest to use summary to export it, but you can definitely do that, right? But
Okay.
I wouldn't use this function to do that. So there are a few ways, like this is solely focused. This is solely focused on data visualization, right? So
Mhm.
if you want to do that, then we can talk about that in a separate session.
Okay.
Yeah, but I mean, you can get any any values out of R into whatever format you want. Okay, so we got that. So we know the structure. There are alternating columns within Siemens and CBS. We check the structure. We check the missing value. Is a good data set, and we can go ahead with the graphing. But imagine, so you can look at the data set by clicking over, like bringing your mouse over it and then click on it. So imagine you have a column, and then the column name has values, right? So by that, I mean that the column name indicates whether it is Siemens or CBS. So these are values, right? Because they vary. And they also indicate which cytokine is it, the column is. So essentially, it is not a good idea to put values as a column name. Okay, it is what is called it is not a tidy data. So a tidy data basically means that basically, like, there are three big rules, right? Fundamental rules. One is one row, one observation. So I mean, you may think that, okay, why do we have more than one observation in one row? But that is the reality. So in reality, you can have more than one observation in a row. And then we have one column, one variable. Okay, so the same, likewise, it can happen. And then the cell, basically like the intersection, right, between row and column, so basically one cell, one value only. So these are like essential rules for a tidy data set. Okay, but so why do we want tidy data sets? Because of the way the ggplot is structured, we need a tidy data set to create whatever we want. So first, we need a tidy data set. And then essentially that also means that variable names should not contain values. And then as we go along, you will see what I mean by that. Okay, so basically let's go down. I mean, this is the same structure that I'm following. So even like you don't even listen to me, you can just read along and follow the follow the codes, and then it will give you the same results. And yeah, and what we are going to do is like, okay, so how do we do that, right? So I think we are going to change a little bit of this data structure here. So we have the column names that contain values, and then we are going to change this structure so that we have essentially two columns. One is basically one column containing these variable names, and the other column corresponding to that values. Okay, but anyway, I will show you what it means to do what it means by that. So let's do that. Okay, so before we do that, we are going to use what is called a pipe function. Okay, I think those of you already know this, but yeah, for those who don't know, you can press Control Shift M. Okay, so this is Control Shift M for the pipe function. Okay, anyway, so what we want is we want the data set from the left-hand side of the pipe symbol. And then we want to push it down to the next level, right? The reason is we want to write a series of codes. Okay, so how do we do that? This structure is called the white format because you have a really it goes along the horizontal axis, right? And then it goes on. You can have 100 or 1,000 columns. So it is going to be a really wide data set. We want to bring all these columns. So here we have 22 columns. We want to bring all these 22 columns into two columns and make it as a long format. Okay, so we are not going horizontally, we are going vertically from top to bottom. Okay, let's do that. So the function is called pivot. Okay, so because like we are we basically center the data set and then pivot so that the wide form becomes long form, right? So the function is called pivot, and now we say longer, right? So before I do that, we need to run this line, okay? Because we need this packages, tidyverse packages to run that. Okay, essentially this pipe function is coming from the migrate_r package. So this comes from migrate_r package. So tidyverse is a collection of this migrate_r, ggplot, and a few other packages, as you can see here, right? So it is basically saying that you have attached these packages: ggplot2, per, tibble, dplyr, tidyr, stringr, rear, focus, etc. Right? So it's 8 packages that you have attached. So and pivot longer. This function is coming from dplyr. Okay, anyway, function follows by bracket, and then essentially we have to specify the column. Okay, so which columns do you want to change from white to longer? So if you look at the data set, it's every column. Okay, so we will say, we will use a function called everything. So basically it brings, it tells this function that we want everything from this data set to make it as a long format. Okay, that's it. That's all you need to change from white format to long format. And then you can, yeah, just put your cursor anywhere on this line and click run, or you can just select this line and run, right? Whatever you like. So let's run this. So you see, instead of seeing all these 22 variables, what you see is only 2 columns. Okay, one column, the first column contain the cytokine names, sorry, the variable names. And the second column contain the values corresponding to that. Okay. Um. Any questions?
No.
Okay. So yeah, it is pretty straightforward, right? And then you can change this name if you want, but it's okay, right? It's okay if you change it, or it's okay if you leave it. And then the next thing is, okay, the column name, this column has 2 values in one cell. So that is what we mean by here. Like one cell should only contain 1 value. So we need to separate this 2 values into 2 columns so that one cell becomes 1 value. So let's do that. Let's quickly do that. We do that by a function called, so we want everything, so by up to this point, we have the long format, okay? And then we basically feeds the modified data set to the next line. So that is what we do. We use a function called separate. This is also coming from dplyr, I guess. Sorry, tidyr. This is coming from tidyr. It is a part of the tidyverse package as well. So, and then you have to specify which column. Okay. And then we say name, and then into. So we want to separate the column name, the column called name, into 2 columns. Okay, so the first value is called, I don't know, sample, right? Because it indicates sample, right? Or you can call type or whatever you want. And the second value is the cytokine. Okay, so we say cytokine. And then you have to specify what is the separation. Okay, here the separation is by the space. Okay, so you can say SCP, which is a separator, and we just put a space. Okay, and then you run this. So you see now we have 3 columns. The first column is basically sample. The second column is cytokine. The third column is values. Okay, so do you get it?
Yes.
Oh, now there is a lot of data processing. Okay, so if you don't want to do that, then you can just click copy, and then you can just run the whole thing. But now it is, well, we have come so far, right? So I think let's call it a day, and then we will pick up from this tomorrow.
Okay, Neil. Yes, I can
Okay.
find some of these things.
Okay, so yeah, I will. Okay, let me stop the recording.